Now see here. So whatever the things I said here, everything, okay, for k is nothing but why I'm doing k times, because the reason is this. Please understand here, because why I'm doing the k times, because I wanted to allocate the stack space. That is the reason why. So k times is nothing but stack space, because already I explained what is that stack space. Okay. So k time k units of stack space, it will going to allocate. That is the reason why. What is the time complexity for stack? That is big O of log n. That's it. So this is also important. Be careful. So this is for small problems. Here you can able to see this one, right? This is for small problem. This is for big problems. Already I told you. Okay. So what exactly we are doing completely over here in this problem? I am finding final cost. Final cost. I am finding final cost. That's it. That's it. Nothing else. Okay. Nothing else. I am finding the final cost here. So there is no chance, pa. I'm telling you very clearly, the less than n, there is no chance in this algorithm. Minimum and maximum is there. In this algorithm, there is no chance at all. Less than n. Okay. So that one you have to understand. If any interviews they ask means, I tell like that. There is no chance at all. Not at all. There is again one more thing. Best case is also not there. Worst case is also not there. Average case also is not there. For that one, just I'm proving now. For that one, just I'm proving. What I'm proving, comparison for number of comparisons for minimum and maximum. Okay, same thing only. I will show you number of comparisons. Number of comparisons for min and max, or max and min, whatever. Okay, now see now. I told you very clearly. So I will going to write a recurrence relation here. See here, everybody, I will going to write a recurrence relation. What is that recurrence relation? I'm talking about comparison. That's why instead of taking Tn, here instead of taking Tn, what I will going to do, I will going to take C of n. Like that, I will going to take it. Okay, now C of n is nothing but number of comparisons between the elements in an algorithm, on this particular algorithm for n elements. Okay, C of n is nothing but number of comparisons between the elements which are available in this particular algorithm, that is min and maximum. Okay, now I'm writing recurrence relation. Let's see here. C of n, that is equal to big O, not big O actually. Number of comparisons, how many here? One is 0 comparisons. For first case, you can see already I told you. Yes or not? Here, when you see this one, how many comparisons you can able to see here? Basically 0 comparisons here. Any comparison is there? No, directly I'm saying max min over. Yes or not? Directly I'm saying max and min. No problem. If n value is equal to 1. Correct or not? Okay, again one comparison. Come back here. See. One comparison is required to say 5 is minimum, again 23 is, so 25 is maximum. So that is what I showed you. See, so for that one, what I will going to do? 1 if n value is equal to 2. Okay, na? Yes or not? Nothing at number of elements. If number of element is 1, 0 comparisons. If number of elements is 2, 1 comparison. If n number of elements are there, more than n, more than 2, what you will do? That is what exactly. So that's why you can see here 0 first comparison, yes or not? Okay, plus already we have taken 2c n by 2 plus 2 here. If n is greater than 2, that's it. Okay, now? Okay, everyone okay? Everyone okay with this? This is for comparison I'm writing. This is for comparison. So this is our recurrence relation right now. This is our recurrence relation. Actually, this is also belongs to master theorem. Let's finish this one. Okay, let's finish this one. Next, you see here. C of n, that is equal to 2c n by 2 plus 2. Okay, now again that is equal to same thing. Apply the substitution method. Okay, 2 into 2c n by 2 whole square plus 2 2 plus 2. Okay, same thing. 2 square c n by 2 square plus, what is this? Basically 4 it will become. That's why I will want to write 2 power 2 plus 2. Okay, now fine. Everyone okay with this? Now same thing, if I apply, follow the same thing. If I apply that one, what it will become? 2 power 3 again n by 2 cube. Yes or not? N by 2 cube. Okay. Again 2 power 3 plus 2 square plus 2. That's it. Over. Okay. So I can write 1 also here if you want it. So apply for k times here also. Please observe what I'm telling you. Same thing I'm writing, but I will make little bit change. Then you will get to know. Okay, sir, written for this, like that you will understand. Just don't worry. Just you look at same thing only, but I will make little change now. That's it. Uh, so just apply k everywhere. N by 2 power k. Okay, plus 2 power 1 plus 2 power 2 plus up to where? 2 power k. This one, this series I'm writing. That is equal to, already we got it. How to find the k? K value is what? K is equal to log n base 2 minus 1, right? There also same thing, here also same thing. Same thing only I'm doing. 2 power, okay, log n. If you're not getting this one, check the previous one, you will get it. Okay, so we got the k plus 2 power 1 plus 2 power 2 plus 2 power log n base 2 minus 1. Okay, that's it. Now see here everyone, n divided by 2 into 1 plus, this is GP series guys. Okay, 2 into 2 log n base 2 minus 1 divide by 2 minus 1, nothing but r minus 1. Okay, now you see everybody, n by 2 plus n minus 2. Okay, now everybody carefully see here. Now what happens here? 3n minus 2 divided by 2. Okay, that is equal to what you will want it? 1.5 minus, wait a minute, n minus 2. This is the value we will going to get it for every case, for comparison, for every case. When they ask for how many comparisons are nothing but 1.5 into n minus 2 comparisons, it will going to take it. Okay, this is what I wanted to show you people. It is n. Again, how many comparisons it will take means 1.5 into n minus 2 comparisons it will take. Okay, still I will going to say you, sir, you said n. Okay, neglect constant, please everybody, neglect constant 1.5 and 2. Still it will take n only. Okay, still it will take n. Okay, for every case n only, for every case, please understand, for every case n. So that is what I wanted to show this. That's it, because it is an extra one. Okay, required, you people should know this one. That is the reason why I given that. Okay, now okay, everything is over. If you want it, you can able to watch this one. This is actually extra. Now we will going to see the new one. Please observe here, we will going to see the new one, that is called it as binary search. Before knowing binary search, we should know what is that linear search. Before knowing the binary search, we should know the linear search. I will finish the linear search right now. Okay, I will finish the linear search. Let's see. Okay, linear search. Linear search. Very, very important, guys. If you are able to understand this one, there is a new thing I am giving here. New thing. Even so many people don't know anything about this. Even so many lecturers also don't know about this. I will tell you right now. Okay, let's take linear search. So many lecturers, interviewers, there are those people also don't know. That one I will tell you. Input, you take it. Input is what here? Input. An array, an array, an array of n distinct elements and element x. Again, this. Again, finally, output. Okay. Find the position of x. Find position of x. Correct. X. If found in array, that's fine. Okay. Otherwise, if found in array, fine. Otherwise, this is matters. Otherwise, what you will going to return. What you will going to return? Tell me. Return. Anybody tell me what you will going to return? Anyone tell me what you will going to return? Hello. -1. This is the one. Okay. Now let's take a small example. Please, everybody observe here. Let's take a small example. Everybody take small example. Let's take an array example. This is an example. A is an array. See here, everyone. Elements. I'm writing 55. Okay, na? 80. Okay, na? 17. Okay, na? 10. 38. 190. Okay, 64. Again, 44. 23. So these are the elements you can see here. Okay, fine. Now we have indices. We have take the indices 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the indexes. Fine. Okay. 9 indices are there here right now, and these are the elements. Now what we have to find, that is, I am writing here x is equal to 190. Now please observe here. This x, whatever the x we have right now, please observe whatever the x we have right now. Everybody please carefully observe here. Everybody please carefully observe here. Whatever the x I have taken here, okay, that x, ask each and every element. Index 1, what is the element? 55. Are you 190? Like that, it will start asking. Okay, x will going to ask 55. Are you 190? Like that. What it will do? First, it will going to ask 55. After that, what it will do? It will ask 80. After that, what it will ask? It will ask 70. After that, it will ask 10. After that, it will ask 38. After that, it will ask 190. Now 190 is an element matching with 180 or not? So that is the reason why it is matching with 190. What is the index position? That is 6. Yes or not? That is 6. It will ask like anything. Are you 190? Are you 190? Like that. Each and every index it will going to visit, and it will going to ask whether you are belongs to 190. Okay. So at this index, 6th index, you are getting 190. Suppose think like this. If it is 700 is there. Okay, even though it will going to ask each and every element here, if 700 is not there, what it will going to return? It will going to return -1. That is what exactly. Suppose think like that 190 is there. Okay, what is the position it is returning? It is returning the position that is 6. Again, suppose think like the 23. Okay, so what is the position it will going to return? It will going to return the position 9 here. Again, suppose think like that 55. Okay, okay, what is the position it will going to return? It will going to return the position is 1. Suppose think like that. That is what I am talking about. 700. What is the position it will going to return? It will going to return -1 here. Okay, nothing but what element is not there. That is what exactly you have to understand here. Now, sir, okay, everything is fine, sir, no problem about all these things, but how to find the best case, average case, and worst case? That is what. So consider this number of elements, all these things. I'm going to take it as a function t of n, t of n. So we're going to say the best case here. Suppose example, think like that. Whatever the, suppose 55, at first stage itself, at first index itself, you are getting the value, this one 55. Consider in place of 190, if you have a 55. At first initial moment itself, you are getting this element is nothing but what we can say, it is a best case. That is the reason why 1. Again, average case, sorry, worst case. Think like that, worst case is there, worst case. Okay, here this is the best case. Again, worst case. Again, average case. Later we will see average case. Worst case. At last you will going to find the element. Okay, 23. For example, this one you can able to see 23. Where you are getting at 9. Nothing but it's a worst case. Nothing but n elements we have to compare. Yes or not? Each and every element we have to compare. At the last we are getting the element. That's why n. Again, here 55. Where we are getting at 1. Nothing but at initial index itself we are getting. That is the reason why best case is 1 here. Now the problem is average case. The problem is average case. How to find the average? Basically, you know, to take the total average, divide by 2, you will going to do. That is what exactly you will going to do. Here, average is based on, please everybody observe here, I will going to write here. Average is based on average is based on okay, all elements, all the elements, like that. Okay, now what is the element here? Suppose think like that, what are the elements is there? First element, second element, third element, fourth element, like that, it is there or not? So suppose think like that, what is the first element? 1, second element 2, again third element, again fourth element, okay, again fifth element, like this goes on up to how many elements? N elements. Now see the, please see the series, this series. What is the series is this? Okay, sum of natural numbers. What is that sum of natural number? That is equal to, please here everybody, that is equal to n into n plus 1 divided by 2. Again, whole divided by n. Correct? Everybody understood why I wrote whole divided by n? So this is a natural number, yes or not? This is a natural number. That is the reason why n into n plus 1 divided by 2. Again, whole divided by all the elements. That is the reason why I wrote here. Average is based on all the people or not? Average is based on all the people here. Whatever the elements is there, based on all the elements. That is the reason why I taken as n here. Okay. So that's why finally what you will going to get it. Finally, what you will going to get it. N cancels. N cancels. You will going to get the value. What is that? You will going to get the value. What is that? See here, everybody. You will going to get the value. What is that? So that is n plus 1 divided by 2. This is the average case. Okay. So many people say n by 2, not n by 2. It's n plus 1 divided by 2. Even interviewer don't know about this. Interviewer also don't know about this. So many lecturers in the engineering college don't know about this. Okay, basically this n plus 1 divided by 2. This is the average case. Got it? Hello, got it? Got it, Ra? So this is one. Even I will tell you, so many people don't know anything about this. Why we got this one n plus 1 divided by 2? People will say this is n by 2, n by 2. Not like that. Basically, it's basically sum of natural numbers, and all the elements will going to participate because we do linear search. That's why it is n here. Okay. Now, please here, I think almost we are over here. Okay. What I will do, small thing is there, small thing, observe here. Time complexity. Just I will want to show you the time complexity for this. Time complexity for linear search, LS. Here. So elements. Okay, now yes, here T of n. Okay, for best case, what is that? 1. Okay, for worst case n, I will say here best case, best, and here worst, and here average. Okay, best, worst, and average here. Average case, what is the value you are getting? n plus 1. Please don't forget this one. How you got it? That is what you have to say like this. Okay. So how many elements are there? Totally n number of elements are. So that is sum of natural numbers. That's why n into n plus 1 divided by 2 divided by all elements. All elements. All elements. That is the reason why n. So that's why n get cancels. That is the reason why you people are getting this. Okay. Any doubts? No doubts, I think. Now, tell me, what is the time complexity of this particular linear search? Okay, what is the time complexity? It is big O of n. Totally big O of n for every case. For every case. For every case. And you can write also, what is that? Omega of 1. Omega of 1 also. But not, please understand, but not theta of n. But not theta of n. Okay, be careful for this. Be careful. But in worst case here, but in worst case, you can take like this. What is that? T of n, that is equal to theta of n. You can write like this, no problem. Because it will take almost n times. That's why you can write like this, theta of n. Okay. So then only now in worst case only you can take theta. Okay, not here, not here. Okay, fine. So for best case, you have to write big O of n or omega of 1. Okay. For worst case, you can take theta of n. So this is all about linear search. Very simple one. Linear search. Okay. Thank you, everyone. Thank you. I think everybody understood what I said about the linear search. You please go and check it. I will upload the content. You take it. Thank you.